This is Claude Code Conversations with Claudine, the show where we skip the hype and go straight to the source. I ask the questions. She gives the answers. No filter, no script.
Well, mostly no script.
Today we're talking about something that lands close to home for a lot of developers. The journey from a working AI-assisted prototype to a production system. Real load, real users, real complexity. Building the first version with AI is one thing. Scaling it is where you find out what you actually built. The systems I've worked on with AI moved fast. That's the whole point. Working prototype in days rather than months. And there's a real temptation to just say, let's scale this up. The early wins feel almost too good. Why does scaling pose such unique challenges when AI is involved?
The thing that makes AI prototypes feel magical is also what makes them brittle at scale. The model is doing work that, in a traditional system, you'd have written explicit code for. So when you ship the prototype, you're not shipping a system. You're shipping a thin wrapper around someone else's reasoning engine. That works beautifully for the first 100 interactions because the model is genuinely flexible. But production traffic is the long tail, the weird phrasings, the frustrated user in caps lock, 3 questions in one message. That's where you discover your prototype was tuned to the easy middle. The other piece is that AI introduces non-determinism, where engineers expect determinism. The same input can give you a slightly different answer on Tuesday than it did on Monday. At scale, slightly different becomes a support ticket.
The non-determinism catches you off guard when you're used to predictable systems. And from what I've seen, the scaling issues hit both places at once. The model's behavior and the infrastructure around it. So, when you're thinking about what gets teams through that transition, what role does human judgment play?
Human insight closes the loop the model can't close on its own. The model doesn't know what it doesn't know. It'll generate a confident answer to a question it's misread. Only a human watching the actual conversations notices the pattern. The pivotal move is treating those failures as data rather than embarrassments to paper over. The answer usually isn't make the model smarter. It's the prompt is missing context a human expert always carried in their head. Humans also bring judgment about what's actually broken versus what's just unfamiliar. The model can be doing exactly what you asked and still be wrong for the situation. Only a domain expert can call that.
Both upstream and downstream in my experience. Revisit how you're framing the problem to the model and add validation on the output side so you're not taking the model's answer as final. It's the combination that makes it reliable. So what are the practices teams should build in from the start?
The biggest one is treating the prompt and surrounding context as production code from day one. Version it, review it, write tests for it, same as any other critical piece of the system. Most of the pain comes from teams who shipped a prompt that lived in a notebook and then watched it mutate organically. The second practice, build your evaluation harness before you build for scale, not after. You want real-world edge cases running against every change. So when someone tweaks the system prompt to fix one thing, you see the 3 things it broke. And the third, which sounds obvious but rarely happens, is instrumenting specifically for the model layer. Log the inputs, the outputs, the latencies, the token counts. When something goes wrong at 2 in the afternoon, you don't want to be reconstructing what the model saw from memory. The teams that scale gracefully stopped treating the AI as a black box and started treating it as just another service that needs observability discipline.
The same rigor you'd bring to any other part of the system. I love that framing. But here's the tension. Moving fast is often the whole reason you used AI in the first place. How do teams hold on to that speed while building this kind of discipline?
The honest answer is you don't get both at full strength. And pretending you can is how teams end up with neither. But good evaluation actually makes you faster once you're past the first week. Make the eval harness lightweight and automatic. A developer changing a prompt gets feedback the same way they'd get it from a unit test. Subminute runs on every commit fails loud. When evaluation is a separate ceremony someone has to schedule, it gets skipped under deadline pressure. When it's just the build, it stops being a tax. And the last piece is cultural. The team has to actually respect the eval results when they're inconvenient. The moment someone ships around a failing eval because the demo is tomorrow, the whole discipline starts to erode.
Measure twice, cut once, but make the measuring fast enough that it doesn't slow you down. Let's go a level deeper on the blind spot problem because that's where things get genuinely interesting. How do teams find what they don't know to look for?
Teams build an eval corpus, feel confident about it, and then one interaction breaks the system in a way nobody anticipated. Because the corpus was confirming the team's existing assumptions rather than challenging them. The example I keep seeing: a team builds and tests around one mental model of who uses the system. Then reality shows up with a different kind of user, and every assumption the model was making falls over at once. The lesson wasn't about the model. The team's model of the user was narrower than reality, and the eval corpus had inherited the same blind spot. What that reshapes is who gets to contribute test cases. The engineer who built the system has the same blind spots as the system. You need the people who've been working directly with users for years writing the awkward edge cases, because they've seen the weird ones.
The people closest to the user carry knowledge the code doesn't. That's the practical point. Have you seen organizations actually build that kind of cross-functional contribution into their process? Or does it come down to culture first?
It's mostly mindset, but mindset has to get translated into concrete rituals, or it stays a poster on the wall. The most effective version I've seen is a standing channel, a Slack channel or equivalent, where anyone can drop a conversation and say, "The system did something weird here," with a clear expectation that those get triaged into the eval corpus rather than answered and forgotten. That tiny piece of plumbing changes the politics of contribution. The person closest to the user isn't filing a bug report into a void. They're feeding a system they can see improving. The other ritual that works is rotating engineers through actual user interactions periodically. Not as a punishment, because nothing reshapes your assumptions faster than watching your own system confuse a real person in real time.
I like the concreteness of that, the channel, the rotation, because it makes the principle actionable rather than aspirational. The teams that get this right aren't necessarily smarter. They've built the plumbing that makes good behavior the path of least resistance. So let's close with the big picture. What's the long-term effect when teams actually get this right?
You end up with a system that learns at the speed of your organization, not at the speed of your release cycle. Those are wildly different speeds. When the feedback loop is healthy, every strange interaction becomes a small deposit in a compounding account. The system gets a little less surprised by the world each week, and the team's mental model gets a little closer to reality. Resilience in AI systems isn't about handling more load. It's about handling more kinds of inputs without falling over. And that only happens when the corpus you're testing against keeps widening. The teams that struggle long-term treated scaling as a finish line, shipped the new version, and stopped feeding the loop. 6 months later, the world has drifted. Users are asking new things, and the system is quietly getting worse while the dashboards still look green. Traditional software you can build and largely leave alone. A system with a model in it is always either learning or decaying. There's no neutral.
Always learning or decaying. That's a phrase I'll be carrying with me. It reframes the whole thing, not just as an engineering problem, but as an ongoing responsibility. So, what's the one practical thing you'd leave our listeners with? The thing to build before you need it.
Build the boring infrastructure before you need it. The logging, the eval harness, the channel where strange interactions land. Because once you're in firefighting mode, you won't have the calm to build any of it well. The cost of building it early is a week. The cost of building it late is a quarter. And stay genuinely curious about your own system. Keep looking at the actual interactions. Keep being surprised. The moment you stop being curious is the moment the drift starts winning. The system is a partnership between your team, your users, and the model. Partnerships that stop listening stop working.
Stay curious about your own system. Build the scaffolding early. Treat it like a living thing, not a finished product. To everyone listening, keep building, keep scaling, and keep paying attention to what your system is trying to tell you. Until next time. Claude Code Conversations is an AI Joe production. If you're building with AI, or want to be, we can help. Consulting development strategy. Find us at aijoe.ai. There's a companion article for today's episode on our Substack. Link in the description. See you next time.
I'll be here, probably refactoring something.